Question 9, the last one on the paper. We're given an expanded version of a circle and we need to find its centre and radius. Okay, this is a completing the square job for the x's and the y's separately within that equation. So first step might be to write out the equation but rearrange the terms so you've got the x terms together and the y terms together. And then complete the square for x squared minus 6x. And complete the square for y squared plus 4y. And that all equals 12. And then just move the minus 9 and the minus 4 to the other side of the equation to get our answer. Well, it's not our answer, sorry, that's our correct form of a circle equation, which allows us to read off the centre, which is 3 minus 2, and the radius, which is 5. Okay, part B. We're given 2 points. We're told they lie on C. We don't have to show that. We're asked to show that PQ is a diameter. Well, there's a few ways of actually doing that, but I think the most efficient way is just to show that if we can find the distance between those 2 points and show that it's 10 units, that's twice the radius, and therefore it must be a diameter. So, as we've used several times already this paper, use the distance formula. So distance between the x coordinates of P and Q squared plus the difference between the y coordinates of P and Q squared. Expand or simplify that down and we end up with the square root of 100, which is 10. Don't forget to conclude because it's a show that, so we need to say which is double the radius, so it's a diameter. And finally, part C. This is geometrically quite fiddly unless you're good at drawing a diagram. So drawing a good diagram here and being savvy with your circle theorems means you'll spot that this is actually not a hard question. Not mathematically or algebraically anyway, but I think conceptually it's not straightforward at all. So let's draw what we've got. That's a sketch of where a circle lies. I'm going to draw the diameter. Notice I've been fairly true to the coordinates. So P was minus 1, 1, so just to the left and above the origin. And that forces Q to be down there on the bottom right, but that seems also to correspond with its coordinates. You can mark on the centre, mark on Q, mark on P, and I have gone way too far ahead there. Excuse me. So, read the question carefully. The point R lies on the positive y-axis. It doesn't say it lies on the circle, though. The angle PRQ is 90 degrees. But, again, as I said a moment ago, if you're savvy with your circle theorems, you'll spot that if that is a 90-degree angle, then it actually has to lie on the circle. It has to, because of the semicircle theorem in the circle theorems. So, drawing that on, showing it's a right angle, you can sort of see clearly now that because it's a right angle, it has to sit on the circle. That's just the way it has to be. So this question just boils down to, where does the circle strike the y-axis? And then we'll take the positive answer of the two, because obviously there's two answers to that question. So we're going to, the y-axis is where x is 0. The circle equation, we could use this one, but it's actually quicker, more efficient to use the original one. Because if we're going to set x to be 0, we want y in its already expanded form to be able to solve it. So we're actually going to substitute x equals 0 into this equation. Let's do that. So x squared is gone, we just get y squared, minus 6x is gone, so we just get plus 4y, and that equals 12. Solve that as we do with any quadratic, set it equal to 0. It factorises nicely, and therefore we're just going to go with y equals 2 as being the coordinate we want. Y equals minus 6 is the answer that we don't want. And then just to actually answer the question that's being asked, R has coordinates 0, 2.